Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to wrap up our introduction to Kubernetes season. Before we dive in, I'd like to remind our amazing listeners to rate our podcast on whatever platform you're tuning in from. Your feedback means the world to us. Now, let's get started with a quick quiz question. In what year was Kubernetes first released to the public, and which tech giant was behind its creation?
That's an excellent question, Sheila. It really takes us back to the origins of Kubernetes. I'm sure our listeners are racking their brains trying to remember which of the big tech companies might have been behind this game-changing technology. Without giving away the answer, I can say that the creation of Kubernetes was a response to the growing need for efficient container orchestration at scale. It's fascinating to think about how quickly it's become an industry standard since its release.
Absolutely, Victor. The rapid adoption of Kubernetes has been nothing short of remarkable. Now, before we delve deeper into our season's summary, let's quickly define some key terms for our listeners. Victor, could you give us a brief explanation of what we mean by container orchestration and declarative model in the context of Kubernetes?
Certainly, Sheila. Container orchestration is like being a conductor of a large orchestra. It's about managing and coordinating many containers at once, making sure they all work together smoothly. The declarative model, on the other hand, is a way of telling Kubernetes what you want your system to look like. Instead of giving step-by-step instructions, you're saying, "This is how I want things to be," and Kubernetes figures out how to make it happen.
Thank you, Victor. That's a great foundation for our listeners as we recap this season. So, let's start at the beginning. We kicked off by exploring what Kubernetes is and why it was created. Could you summarize the key points we covered about the history and evolution of Kubernetes?
Absolutely. Kubernetes, often abbreviated as K8s, that's K, followed by 8 letters, then S, emerged from Google's internal container management system called Borg. It was released as an open-source project in 2014, building on nearly 15 years of experience running production workloads at Google. The goal was to create a platform that could manage containerized applications across multiple hosts, providing ways to deploy, maintain, and scale applications easily.
That's right, and it's amazing how quickly it gained traction in the industry. I remember we discussed several use cases and benefits of Kubernetes. Could you remind our listeners of some of the key advantages we talked about?
Certainly. Some of the primary benefits we covered include 1. Automated rollouts and rollbacks, 2. Self-healing capabilities, 3. Horizontal scaling, and 4. Efficient resource use. Kubernetes also provides service discovery and load balancing right out of the box, which makes networking for containerized applications much simpler. Perhaps most importantly, it offers a consistent environment from development to production, making it easier to build and deploy applications reliably.
Those benefits really highlight why Kubernetes has become so popular. Now we spent quite a bit of time talking about containers, particularly Docker. Victor, could you give us a quick recap of what containers are and why they're so important in the context of Kubernetes?
Of course, think of containers as lightweight, standalone packages that include everything needed to run a piece of software. They're isolated from one another and from the underlying system, which makes them highly portable and consistent across different environments. Docker made containers popular by providing tools to build, run, and manage them efficiently. Kubernetes then came along to solve the problem of orchestrating these containers at scale, especially for large, complex applications.
That's a great explanation, Victor. You know, I've been thinking about an analogy that might help our listeners understand the relationship between containers and Kubernetes. What if we compare it to a city's infrastructure?
That's an interesting idea, Sheila. How would you draw that parallel?
Well, imagine containers as individual buildings in a city. Each building, container, has everything it needs to function independently: plumbing, electricity, etc. But for a city to function efficiently, you need more than just buildings. You need roads to connect them, utilities to serve them, and systems to manage resources. That's where Kubernetes comes in. It's like the city's infrastructure and government combined. It manages how the containers are connected. ensures resources are distributed efficiently, and maintains the overall health of the system. Does that analogy work? Or am I off base?
That's actually a brilliant analogy, Sheila. It really captures the essence of how Kubernetes works. To extend it further, we could think of Kubernetes master node as the city hall, making decisions about resource allocation and management. The worker nodes would be like different districts of the city, each hosting multiple buildings, pods. And just as a city planner uses zoning laws and building codes, Kubernetes uses declarative configurations to determine how the city should be structured and run.
I'm glad you like the analogy. Now, speaking of structure, let's shift gears a bit and discuss Kubernetes architecture. We spent a good amount of time on this topic. Could you summarize the key components we covered?
Certainly. At a high level, a Kubernetes cluster consists of a master node, or control plane, and one or more worker nodes. The master node includes several critical components. 1. The API server, which acts as the front end for the Kubernetes control plane. 2. T3D, a distributed key-value store that stores all cluster data. 3. The scheduler, responsible for assigning workloads to nodes. 4. The controller manager, which runs controller processes. Worker nodes, on the other hand, include 1. Kubernetes, an agent that runs on each node and ensures containers are running in a pod. 2. Container runtime, like Docker, which runs the containers. 3. Kube proxy, which maintains network rules on nodes. These components work together to maintain the desired state of the cluster, as defined by the user through the declarative model we mentioned earlier.
That's a great summary, Victor. You know, one thing I found particularly interesting was the declarative model. I think it's a concept that can be a bit challenging for newcomers. Could you elaborate on why this approach is so powerful and maybe highlight some common misunderstandings?
Absolutely, Sheila. The declarative model is indeed a powerful concept, but it can be tricky if you're used to more traditional ways of managing systems. In the declarative model, instead of giving step-by-step instructions, you simply describe what you want the end result to look like. Kubernetes then works continuously to make sure the actual state matches this desired state. One common misunderstanding is thinking that you need to tell Kubernetes how to get from the current state to the desired state. In reality, Kubernetes handles all of that for you. Another mistake is not realizing that this is an ongoing process. Kubernetes doesn't just set things up once and forget about them. It's constantly working to maintain the declared state. The power of this approach lies in its simplicity and reliability. It allows for self-healing systems, easy scaling, and consistent environments. You can version control your infrastructure as code, making it easier to manage complex systems and roll back changes if needed.
That's a great explanation, Victor. I think it really helps clarify why the declarative model is so fundamental to how Kubernetes operates. Now, we've covered a lot of ground in this season. Before we wrap up, is there an interesting fact or anecdote about Kubernetes that you'd like to share with our listeners?
Certainly. Here's an interesting tidbit. The name Kubernetes comes from Greek, meaning helmsman or pilot. This nautical reference is fitting, as Kubernetes steers the ship of containerized applications through the sometimes turbulent seas of modern infrastructure. Another fun fact is that the 7-spoked wheel in the Kubernetes logo isn't just a cool design. It's a nod to the project's original codename, Project 7 of 9, a reference to a Star Trek character. This shows the playful side of the developers and the project's roots in Google's engineering culture.
Those are fantastic facts, Victor. I love how they tie into the nature of what Kubernetes does. Now, before we conclude, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The answer to our quiz question is, Kubernetes was first released to the public in 2014, and it was created by Google. However, it's worth noting that shortly after its release, Google donated the project to the newly formed Cloud Native Computing Foundation, making it truly open source and community-driven.
Thank you, Victor. To wrap up our season on Introduction to Kubernetes, let's summarize the main points we've covered. 1. Kubernetes is a powerful container orchestration platform that automates the deployment, scaling, and management of containerized applications. 2. It originated from Google's internal system Borg and was released as open source in 2014. 3. Kubernetes works with containers, particularly Docker containers, to provide a consistent environment from development to production. 4. The architecture consists of a master node, control plane, and worker nodes, each with specific components that work together to maintain the desired state of the cluster. 5. Kubernetes uses a declarative model, where users describe the desired state, and Kubernetes works to maintain that state. 6. Key benefits include automated rollouts and rollbacks, self-healing, horizontal scaling, and efficient resource utilization. We've only scratched the surface of Kubernetes in this introductory season, and there's so much more to explore in the world of container orchestration.
Absolutely, Sheila. It's been a fantastic journey through the fundamentals of Kubernetes. I hope our listeners have gained a solid foundation and are excited to learn more. Remember, Kubernetes is a vast and evolving ecosystem, and there's always more to discover.
Couldn't agree more, Victor. And to our wonderful listeners, we want to thank you for joining us on this Kubernetes adventure. If you've enjoyed the show and found it helpful, please consider supporting us. Visit crashcasts.com to learn more about our podcast, join our Discord community for great discussions, or support us on Patreon if you're able. Your support helps us continue creating this content. Don't forget to subscribe to the podcast and rate us on your preferred platform. It really helps others find us. Until next time, keep on crashing.